Welcome. PSM 201, Study Section 6, Probability Theory and Probability Distribution. Introduction. Probability theory is a tool that was created to deal with the world events that seems unpredictable. For example, before getting a surgery, a patient wants to know the chances that the surgery might fail. Before taking medication, we want to know the chances that there will be side effects before leaving our houses. We want to know the chances that it will rain today. All of these deals with everyday life, and all of them have to do with chance or probability. In this study section, you will learn what probability and its properties are, how probability behaves, and how to calculate and use it. This basic probability concept will provide a foundation for understanding more statistical concepts. You probably already intuitively use concepts from probability knowingly or unknowingly. But after this section, you will be able to formally and precisely predict the likelihood of an event occurring given certain constraints. At the end of this study section, you should be able to explain probability and its rationale in health science, explain probability distributions. Probability and its rationale in health science. Probability is simply defined as the likelihood or chance that something will happen. The words like might, almost, or certainly are used to indicate how likely or unlikely an event is. Probability provides a measure of the uncertainty or certainty associated with the occurrence of events or outcomes. It is a necessary and useful tool in exploring and quantifying relationships. Properties. Probability deals with the chance of an event occurring. It is a measure of likelihood that takes on value between 0 and 1, inclusive with 0 representing impossible events and 1 representing certainty, and the chances of events occurring fall between these two values. It can only take values between 0 and 1. As illustrated in the figure above, the following are true about the probability values. It is non-negative. P(E) is equal to 0. This means the event cannot take place. P(E) is equal to 1. This means the event is sure to take place. 0 less than P, E less than 1, P is equal to 1 minus Q, such that P plus Q is equal to 1, where P is the probability of occurrence of an event, Q is its complement, probability of non-occurrence, and PE is the probability of an event. Why the need for probability in health? Physicians need to take decisions of patient diagnosis and draw up treatment plans based on the available information from the patient's past through medical history, clinical examination, radiological investigation, ECG, personal experience, etc. Medicine is an exact science basic to statistical inference on survival patterns, basic to decision-making for patient management in the face of numerous uncertainties such as diagnosis, treatment, prognosis, allows us to measure the degree of uncertainty, allow translation of data into decisions about the nature of our world. Basic concept of probability. The following are the basic approaches to defining probability. A. Classical. Ratio of number of outcomes where event A occurred, NA, to the total number of possible outcomes, N, favorable or unfavorable. That is, ratio of those with defined attribute to total possible outcome, PR into bracket A, is equal to N into bracket A over N. Frequentist. This approach makes use of relative frequency of occurrence in a long series of trials, Some process or experiment is repeated for a large number of times. N. And if M events possess the characteristic A, then the relative frequency of occurrence of A, M over N, will be approximately equal to the probability of A. P into bracket A is equal to M over N. In other words, it is the long proportion of times an event will occur in repeated identical repetitions of an experiment. Subjective. As the name implies, this is subjective and is based on the degree of belief. Example, for an illustration, example on both the classical and frequentist approaches to defining probability is here illustrated. Some basic probability terms and definition. Experiment. Any process which, when repeated, generates a set of results of observation is referred to as experiment. In statistics, an experiment may not necessarily be laboratory based, e.g., throwing a coin. Trial. A particular act of any experiment is known as a trial. Outcome. The result of a trial is called an outcome. Sample space. Sample space refers to the population of all possible outcomes of an experiment. Equally likely. This is the term used to describe the situation when all outcomes of the experiment have the same chance of occurrence. Event. It is a subset of sample space, an outcome or a set of outcomes of an experiment defined by a given rule, e.g., tossing a coin 3 times. Event A, getting exactly 2 heads. HTH, HHT, THH. Types of events. Simple events. Events with only one possible outcome of interest. A particular result of an experiment. Compound events. Events with more than one possible outcome. Mutually exclusive events. 2 events, say A and B, are said to be mutually exclusive if they cannot occur together, e.g., having a male prevent a male child in a single birth. Independent events. The occurrence of one event does not affect the occurrence of the other event. Examples. Suppose there are 40 patients, characteristic A, and 30 individuals, age less than 30 years. Characteristic B. If we are told that there are 20 patients, age less than 30 years, then the intersection of set A and B is the set of 20 patients aged less than 30. That is, the intersection is the joint occurrence of individuals who are patients and of age less than 30 years. The union of set A and B is the set of all individuals who are patients or aged less than 30. This implies that the union of set A and B is determined by adding up the total number of each set and then subtracting out the individuals common to both sets. That is, set A equals 40 plus set B equals 30. Total is equal to 70. Common is equal to 20. Union is equal to 50 unique individuals. The union of these two sets, A or B, consists of the 50 unique individuals who have one or both characteristics, A alone or B alone or both A and B. Let's assume there are 50 nursing students, characteristic A, and 20 human nutrition students, characteristic B. Then the intersection of the two sets, A and B, is empty because a student cannot belong to both departments. Set A and B are mutually exclusive, that is, the two departments are mutually exclusive because individual students cannot belong to both departments at the same time. Basic laws of probability. The following types of probability are required for understanding the laws of probability. 1. Joint probability. The joint probability of two events, say A and B, is expressed as P into bracket A intersect B equals P into bracket A and B, When events A and B are mutually exclusive, then P into bracket A and B equals 0. 2. Conditional probability. The conditional probability of an event A given an event B is present as occurred could be expressed as P into bracket A over B equals P into bracket A intersect B all over P into bracket B. If the two events are mutually exclusive, it becomes P into bracket A over B equals 0. If independent event, it becomes P into bracket A over B equals P into bracket A or P into bracket B over A equals P into bracket B. Addition rules of probability. When there are n mutually exclusive events cannot occur together, then the probability of an event is non-negative. P into bracket event A greater than 0. The sum of the probabilities of all n mutually exclusive events equals 1. P into bracket event 1 plus P event 2 plus event n equals 1. The probability of either event A or event B is the sum of the two probabilities since P, A and B equals 0 for mutually exclusive events. This could be expressed as follows. P into bracket event A or event B equals P into bracket event A plus P into bracket event B. P into bracket A or B equals P into bracket A plus B into bracket B. P into bracket A union B equals P into bracket A plus P into bracket B. In general, if two events A and B are not mutually exclusive, then the probability that event A or event B occurs could be expressed as follows. P, A or B equals P, A plus P, B minus P into bracket A and B. P into bracket A union B equals P into bracket A plus P into bracket B minus P into bracket A intersect B. Multiplication rules of probabilities. Multiplication rules applies to the joint probability of two or more events. For instance, it specifies the joint probability for two events as P into bracket A intersect B equals P into bracket A, P into bracket B over A, which is equal to P into bracket B, P into bracket A over B. However, the probability of occurrence of two or more independent events is equal to the product of their respective probabilities. P into bracket A intersect B equals P into bracket A, P into bracket B. Since when event A and B are independent, then P into bracket A over B equals P into bracket A, P into bracket B over A equals P into bracket B. Joint probability. P female and older equals P female intersect older, that is 110 over 200. P into bracket male and younger equals 30 over 200, which is equal to 0.15. Probability of selecting a female or a older diabetic patient using the addition rule of probability. P into bracket female or older equals P female plus P older minus P female and older. 150 over 200 plus 130 over 200 minus 110 over 200 equals to 170 over 200, which is equal to 0.85. Probability of selecting a male or a younger diabetic patient. Using the addition rule of probability, P into bracket male or younger, P male or younger equals to P male plus P younger minus P male and younger, which is equal to 50/200 plus 70/200 minus 30/200, which will give us 90/200. Then we have 0.45. Our two characteristics, sex and age, independent. If sex and age are independent, then the probability of being in a particular age group should be the same for both sexes. In other words, the conditional probabilities should be equal. Probability distributions. Knowledge of probability distribution of a variable allows us to come to conclusions about a population based on data taken from a sample of that population. Recall that a random variable is a numerical outcome of a random event, while a statistical distribution describes the number of times each possible outcome occurs in a sample. A random variable values can vary with each repetition of an experiment. It is an observable that takes on values with certain probability, e.g., the arrangement of events and their corresponding probability in a tabular form, such as the family size X in Nigeria distribution below. By and large, a distribution of the probability of all possible outcomes of a random variable is known as probability distribution. In other words, it is a distribution of data based on the likelihood that an event or indicator will occur in a sample of the population. A probability distribution, therefore, can be either discrete or continuous depending on the values its random variable assumes. Discrete probability distributions. The probability distribution of discrete random variable is the distribution of The probability distribution of discrete random variable is the distribution of random variables that takes on only a countable number of possibilities, e.g., number of accident victims in an emergency ward on daily basis for a period of 1 month. Some examples of these distributions are as follows: Bernoulli distribution, binomial distribution, Poisson distribution, geometric distribution, hypergeometric distribution, negative binomial distribution. Of the above discrete probability distributions, the binomial and the Poisson distribution are very common in health and medicine. Hence, these two common distributions shall be discussed in these units. Binomial distribution. Suppose that n independent experiments or trials are performed, where n is a fixed number, and that each experiment results in a success with probability p and a failure with probability L minus p. Then the total number of successes. X is a binomial random variable with parameters n and p. If you have only two possible outcomes, call them yes or no, present or absent, or success or failure in n independent trials, then the probability of exactly x successes equals r. That is, the probability that x is equal to r is statistically expressed as p x is equal to r. Properties of binomial distribution. Let the random variable x is the number of successes in the n trials. If x follows a binomial distribution with parameters n and p, that is, x approximately b in np, then trial has only two possible outcomes, that is, dichotomous outcome, trial repeated n times. Successive trials are independent. In each trial, there is a constant probability of success p and failure l minus p, the mean or expected value, the variance, such that the standard deviation. Poisson distribution. Distribution of a discrete random variable x with parameter lambda. The average number of occurrences of an event in a given space, time, or volume is known as Poisson distribution. Poisson process is therefore an experiment in which discrete events are observed in a continuous interval of time, space, and volume. If x, number of new cases, and x, approximately Poisson lambda, then the probability that x is equal to r, a particular count, is p into bracket x is equal to r. The distribution tells you the probability of all possible number of new cases from 0 to infinity, where R is equal to number of occurrences of some random event, E is equal to 2.7183, a constant, and lambda is mean number of occurrences. Properties of Poisson distribution. If events happen at a constant rate over time, the Poisson distribution gives the probability of X number of events occurring in time t with the following properties. Poisson distribution is used to model count data. Occurrence of events is random, space, or time. Probability of occurrence very small. In a short interval, it approaches 0. Trial size is large and unknown. Useful for rare events. It is characterized by parameter lambda, the expected value of X. The expected value mean is equal to lambda, which is equal to variance of X. Approximation to binomial distribution. When n is large and p is small, binomial distribution could be approximated by Poisson distribution. That is, Poisson can be applied when n sample is large, such that mean is equal to np is equal to lambda. Variance is equal to np into bracket L minus p is equal to lambda. Continuous random variables are random variables that can take any value on the real line or some subset of the real line, e.g., time, temperature, height, blood pressure, etc. The probability distribution of these random variables is called continuous probability distribution. The following are some examples of continuous probability distribution: uniform distribution, exponential distribution, gamma distribution, normal distribution, chi-square distribution, student T distribution, Will-B distribution. However, the normal distribution, called the Gaussian distribution in honor of its inventor, Carl Friedrich Gauss, will be discussed based on its importance to health and medicine. Normal distribution. The normal distribution is a theoretical probability distribution that is perfectly symmetric about its mean and median and mode. It is symmetric with scores more concentrated in the middle than in its tail. Normal distributions are sometimes described as bell-shaped, used widely in almost all disciplines. There are reasonable descriptions for many variables such as height, blood pressure, body temperature, hemoglobin level, and the likes. Parameters of normal distribution. Normal distributions are uniquely defined by two quantities called parameters, a mean and standard deviation. Areas under a normal curve represent the proportion of total values described by the curve that fall in that range, and the height of the curve can be specified mathematically in terms of the two parameters, the mean and the standard deviation. A random variable x having a normal distribution is usually written in the form x approximately n. However, a normal distribution with a mean is equal to 0 and a standard deviation equals to 1 and is called a standard normal distribution, sometimes called the z distribution. And a random variable z having a normal distribution is usually written in the form z approximately n, 0, and 1. Properties of the normal distribution. It is bell-shaped as represented in the figure 2.1 below. It is symmetrical about the mean value, determined by the mean and variance. Its mean, median, and mode are equal. Total area under the curve is 100%. 68% of total observation approximately lie within one standard deviation left and right of the mean value. 95% of total observation approximately lie within 1.96 standard deviation left and right of the mean value. Over 99% of total observation approximately lie within 2.576 standard deviation left and right of the mean value. Importance of the normal distribution. Some of the importance of the normal distribution are stated below. 1. It fits many practical data distribution in biomedical sciences. 2. It can approximate binomial distribution when n is large. 3. It is the cornerstone of all parametric tests of statistical significance. 4. It is the foundation of other distributions such as chi-square, F distribution, and T distribution. 5. Sampling distribution of means and proportions are generally known to have normal distribution. Standardizing normal distribution. Any normal distribution with any mean and standard deviation can be transformed to a standard normal curve. This process is called standardizing or computing z-scores as demonstrated in the figure 2.2 below. The z-score can be computed for any observation from any normal curve as expressed below. Z is equal to x minus Newman over sigma, where x is the score from the original normal distribution, Newman is the mean of the original normal distribution, and sigma is the standard deviation of original normal distribution. Interpretation. A z-score always reflects the number of standard deviation above or below the mean. In other words, it measures the distance of any observation from its distribution's mean in units of standard deviation. This z-score can help assess where the observations fall relative to the rest of the observations in the distribution. It can also be used to determine areas under the curve. Example: if a student scored 80 on a test in which the mean is 50 and the standard deviation is 10, then the student scored 3 standard deviation above the mean, that is, z is equal to x minus Newman over sigma, which is equal to 80 minus 50 over 10, will give us 3. The area under the normal distribution curve. The area under the normal distribution curve, which could be described as the proportion of the population that has values in some specified range, or probability that an individual observation will lie in the specified range, can be calculated using a calculator, computer, or a statistical table. Examples: given a normal distribution of male height with Newman, which is equal to 171.5 centimeter, and sigma, which is equal to 6.5 centimeter, what is the proportion of men taller than 180 centimeter? To start with, z is equal to 180 minus 171.5 over 6.5 equals 1.31. Now we need to find the area of the standard normal curve above, 1.31. P into bracket z greater than 1.31 equals 0.0951. Hence, the proportion of men taller than 180 centimeter is 9.5%. If the population of men were 1,000, then there are 95 men taller than 180 centimeter. Summary of study section 6. In this study section, you have learned that probability is simply defined as the likelihood or chance that something will happen. Probability provides a measure of the uncertainty or certainty associated with the occurrence of event or outcome. It is a necessary and useful tool in exploring and quantifying relationships. Probability deals with the chance of an event occurring. Knowledge of the probability distribution of a variable allows us to come to conclusion about a population based on data taken from a sample of that population. A random variable's value can vary with each repetition of an experiment. The probability distribution of discrete random variable is the probability distribution of discrete random variable is the distribution of random variables that take on only a countable number of possibilities, e.g., number of accident victims in emergency ward on daily basis for a period of 1 month. Now we've come to the end of study section 6. Thanks for listening.